Hello, everyone. In this video, we're going to begin sections 12.1 to 12.3 in our workbook on functions, graphs, and contours. So in these sections, we begin chapter 12, where we're looking at multivariable functions and multivariable calculus. So to start, we're going to look at a lot of notation, definitions, graphs in 3 dimensions. So to do that, we first need to be able to graph a point in 3 dimensions. So let's do that in example 1. So here in example 1, we're told to plot the points P, Q, R, and S on the coordinate axes to the right. So let's just get our orientation set for how we would graph points in 3 dimensions. So typically the variables that we use are X, Y, and Z. So we can think of X and Y as our typical 2-dimensional XY plane. And then Z is this kind of extra or new third variable that sticks out of that plane, which gives us a 3-dimensional space to graph. So when we see a point like P here, 0, 0, 2, we interpret these coordinates as the X, Y, and Z. And so this is just convention. Just as we see typical points in 2 dimensions, as the X and the Y point. In 3 dimensions, we use X, Y, and Z. So we can see these 3 axes, even though we're representing these 3 axes in 2 space, meaning it's on our flat page. These axes we should think of as existing in 3 dimensions, or this is representing a 3-dimensional display. So if you want to see maybe an example of this in your life, go to a corner of your room where you can see the corner. And then each of these planes is making up a wall, say wall 1, wall 2, and then the floor. So these 3 planes make up that corner of this 3-dimensional space. Okay, let's go ahead and plot some of these points. So first of all, P. So X and Y are 0. So first, considering the X coordinate, we don't go anywhere along the X axis, we stay at 0, the origin. The Y coordinate is also 0, so we don't move anywhere along the Y axis. So we'd stay at the origin for X and Y. And now the Z coordinate is 2, so from there we'd move up 2. So the point here for P would be right here. Okay. And we can just make our axes tick marks a little bit more bold so we can see what's going on here. Okay, so there is P. So now let's do Q. So Q has the X point 3, Y point 4, and Z as 0. So what we do is move 3 along the X axis, 1, 2, 3. Move 4 along the Y axis. So from this 3, we go over 1, 2, 3, 4 along the Y direction. And then we're not going in any direction with the Z. Z is 0. So we'd plot our point right here. So Q is this point here. So Q would be lying on the floor there. So why don't you take a moment to pause the video and graph the points R and S on your own, and then compare your work with the video. All right, so we'll move on to R. So the X coordinate is 0, the Y is 4, and the Z is 5. So we move 0 along the X axis. Along the Y, we move 4. So I'm going to go over 1, 2, 3, 4. And then along the Z, I'm going to go up 1, 2, 3, 4, 5. So I'm going to land right here on the corner of my box. So that would be our R point. And then S, X, Y, Z is 3, 4, 5. So we'd move 3 along the X, 1, 2, 3, 4, 1, 2, 3, 4 along the Y, and then up 5. 1, 2, 3, 4, 5. So we'd be on this other corner of this box here. So that would be S. So you can draw in some more lines just to help you visualize what's going on. So we can see the lines coming out, say, on that XY plane here, and then up here we could draw corresponding lines, or like a grid, say, along the Z and y planes, if we wanted to get a sense of how we'd see those points coming up on a grid. Okay, so for example 1, we just saw how we plot points in 3 space. So those x, y, z points. So in example 2, we're going to look at some functions defined using 2 variables. So with these functions, we're going to input 2 variables. So we should think of that as a coordinate, x, y. We're going to input an x, y, and then we output 1 variable. All right, so in example 2, we're asked to consider the 2 functions f of xy, which is equal to x squared plus y squared, and g of xy, which is always equal to 3. We're going to evaluate f at several values of x and y, and then also create a sketch of g. So let's go ahead and get started together. So let's go ahead and consider what the output of f is going to be on some coordinates. So let's check at the origin, or at 0, 0. Well, here we're going to square 0, add that to the square of 0, so we just get 0. Well, let's try something else. F of 1, 0. So when x is 1 and y is 0, we'd square the 1, square the 0, add them together, we get 1. We can do that with another point, maybe 2, 3. We get 2 squared plus 3 squared, which would be 4 plus 9, which would give us 13. So go ahead and try a few more on your own. Maybe try f of, I don't know, 7, 9, and see what number you get. So you should square the 7 and the 9 and get a number. Okay, so that was just a little bit of work getting familiar with functions of 2 variables. So f here is a function of 2 variables. It's not just a function of x, it's a function of x and y. So now we're going to do the second part of this example where we're going to create a sketch of g. So some notation here, if we have a function like g of xy equals 3, we should think of the input variables as being those xy, and in fact, they're given to us, x comma y. And we should think of the output variable as being a z value, meaning when we go to graph this function, we want to think of graphing this function in a set of planes like this, in a 3-dimensional space that has 3 axes. 2 axes are going to form the basis of our inputs, and then the z value is going to be our output. So let's go ahead and draw that together. So here we can first just draw our axes. So there's my z, and I'm going to do my x and y. So here's my x, here's my y, and here's my z. And so I can also create a scale here. So 1, 2, 3, 1, 2, 3, 1, 2, 3. We could do some grid lines, but that often just gets a little bit more messy. So we're just going to leave it like this for now. All right, so now what we want to do is draw a picture of the graph g of xy equals 3. So let's just think about that graph for a little bit. Well, what this tells us is that for any xy value that we input, so for any xy value, the output is going to be 3. Meaning for any xy input, the output is 3. So any point on our graph, for any xy you give me, the output will be at 3. So what that looks like, we could graph some points. So 0, 0 would be 3. 1, 0 would be 3. 2, 0 would be 3. And similarly over here, if we input 0, 1, we're going to get 3. 0, 2, we're going to output 3. And when you see, when we do this, what we end up getting is an entire plane centered or leveled at z equals 3. So g of xy equals 3. And I encourage you to think through maybe a little bit why this would be the graph. And rather plane at z equals 3. So I'd like you to think through about why this is the graph of g. So we just created an explanation together, but I want you to create your own explanation or maybe restate it in your own words. Awesome. All right, great work going through these first 2 examples.